All right, so we just found that the formula for cotangent of x plus y is just the formula for tangent flipped. I made an algebra mistake, so I'm redoing this. I make algebra mistakes too. All right, so this is going to turn into, so I just copied the formula that we decided that's what's going on in there. So 1 minus tangent of x. So I just look at the x. So notice that these green ones are the opposite and adjacent. So tangent of x is going to be opposite over adjacent. So it's going to be opposite was -4 over adjacent, which was 3, times tangent of y. So now I look in the y. Tangent of y is opposite, which is -12, over adjacent, which is 5. So -12 over 5. And then over tangent of x, which is -4/3, times tangent of y, -12 over 5. All right, so to calculate this, I just reduce whatever I can. This 3 with this 12, I'm going to reduce it by 3. So this I have a 1 and this I have a 4. This 3 with this 12, I have a 1 and a 4. So it looks like what I have left is 1 minus -4 times -4. That's +16 over 5. And then at the bottom, I have -4 over 1 times -4 over 5. So that's going to give me, I'm going to bring it to a common denominator. So this needs a 5. So this at the top, I'll have 5 minus 16 over 5 over -4 times -4 is +16 over 5. All right, so this reduces with that one. And 5 minus -16 is going to be -11 over 16. All right, so if we didn't make any mistakes this time, this should be the answer. Okay. Then we could have these types of questions where we're asked to write this trig expression as an algebraic expression. So this is similar to something that we've seen before. It just looks more complicated now. So I have sine of something minus something else. So when you see something like that, you're like, it would help if this looked like sine of u minus v, because then I can apply the formula. What is sine of u minus v? All right, so if you look at your formula page, sine of u minus v is sine cosine minus cosine sine. All right, so let's just write it here. So sine of the first times cosine of the second minus cosine of the first times sine of the second. So now you're like, but mine doesn't look like this. So what do I do now? Okay, well, how can I make it to look like this? Well, we're gonna let this equal u, and we're gonna let this equal v. And let's see where that takes us. Okay, so let's let arctan of 2x equals u, and arc cosine of x equals v. Okay, so now going back to our inverse trig functions, if arctan of 2x equals u, then the inverse function to arctan, which is tangent of what equals what? Remember, inverse function switches input and output. So this is tangent of u equals 2x. Okay, the tangent of u equals 2x. So now I can draw a right triangle, and let's call this u. And remember, tangent is opposite over adjacent. So this means I can write 2x as 2x over 1. This means that my opposite to u is 2x and my adjacent is 1. So if I want to solve for the hypotenuse, I'm going to say that 1 squared plus 2x squared equals hypotenuse squared. And this is going to give me 1 plus 4x squared equals hypotenuse squared. I'm going to take square root of both sides. Hypotenuse equals plus or minus square root of 1 plus 4x squared. But since we're always dealing with hypotenuse being positive, I'm going to pick the positive one. So this is where I'm going to put for hypotenuse. Square root of 1 plus 4x squared. Okay? Now let's see what this portion is giving us. Since arc cosine of x equals v, its inverse cosine of v must be equal to x. Okay, so then let's draw the v angle. So if v in here, cosine is what? Cosine is adjacent over hypotenuse. So this gives me, I can write x as x over 1. This gives me that adjacent to v is x and hypotenuse is 1. So I can solve for opposite in here doing Pythagorean theorem. So x squared plus opposite squared equals 1 squared. Solving for opposite, I get that opposite squared equals 1 minus x squared. And then opposite equals plus or minus square root of 1 minus x squared. So now, why are we going to pick the positive one? We're going to pick the positive one because, let's think about it. Tangent is positive, right? So this means that opposite and adjacent have to agree on the sign. Okay? And since adjacent is positive, it's 1. Oh, wait, I'm looking at v. Sorry. Never mind. No, it's still in x's. Yeah, we're gonna pick the positive one. Okay, so we'll have 1 minus x squared. All right, well, why did we do all of this? Okay, let's go back to our goal. Our goal is to write this expression. Sine of arctangent of 2x minus arc cosine of x as an algebraic expression. So I'm going to rewrite it in here. Sine of arctan of 2x, we said that that is equal to u. So that's what I'm going to put in here. Sine of u minus arc cosine of x, we let that equal to v. So according to this formula right here, this is going to be sine of u cosine of v minus cosine of u sine of v. Sine of u. So now I'm looking in the u triangle. Sine is opposite, which is 2x, over hypotenuse, which is square root of 1 plus 4x squared, times cosine of v. So I'm looking in the v now. Cosine is adjacent x over hypotenuse, which is 1, minus cosine of u. So I'm looking at u now. Cosine is adjacent, which is 1 over hypotenuse, times sine of v. I'm looking at v. Sine is opposite, which is square root of 1 minus x squared, over hypotenuse, which is 1. So you notice that they have a common denominator of 1, square root of 1 plus 4x squared. And then at the top I have 2x times x, which is 2x squared, minus square root of 1 minus x squared. So this is it. We have wrote this trig expression right here as an algebraic expression. This equals that. All right. If you remember, we have gone over these identities and we kind of gave like a simpler, looking in a triangle, a simpler explanation for why the cofunction identities hold. Now we can actually prove these a little more elaborately. So how are we going to do that? Well, doesn't this look like something familiar? Sine of pi over 2 minus theta. I can use the formula sine of u minus v. So we're going to work with the left hand side. So sine of pi over 2 minus theta, according to the formula, it's equal to sine of u times cosine of v minus cosine of u times sine of v. So in my case, u is pi over 2 and v is theta. So this is going to turn into sine of pi over 2 times cosine of theta minus cosine of pi over 2 times sine of theta. And this equals what? I know that sine of pi over 2 is 1. So it's going to be cosine of theta. Cosine of pi over 2 is 0 times sine of theta. So the answer is just cosine of theta. And that's exactly what I needed to show, that it's equal to cosine of theta. So this is another way to explain the cofunction identities. Okay. So we have two more to try. So to verify this one, cosine of theta plus 2 pi equals cosine of theta. Notice this one is not a cofunction identity, but you should know that this is true because of what? What is the period of cosine? 2 pi, right? So cosine of theta plus 2 pi, it should be equal to cosine of theta because the period of cosine is 2 pi, so the values start repeating. So how do we prove this? Cosine of theta plus 2 pi, we're looking on the left hand side, and we're going to use the formula. The formula for cosine of u plus v. Cosine of u plus v is equal cos cos minus sine sine. So that's what we're going to do. So cosine of theta plus 2 pi equals cosine of theta cosine of 2 pi minus sine of theta sine of 2 pi. Okay, so just filling in the cosine of 2 pi and sine of 2 pi. So this gives me cosine of theta and cosine of 2 pi is 1 minus sine of theta sine of 2 pi is 0. So then the answer is just cosine of theta, because this one goes away. So again, we have shown that this equals that more elaborately using these formulas. All right, so one last one that we're going to prove is this right here. So verify the identity. If you look at it, you're like, okay, how am I going to tackle this? Do I start with the left-hand side or start with the right-hand side? If you look at the right-hand side, this should look familiar. It's tangent of something plus something else. So tangent of u plus v. And we know that we have a formula for that. So this is the clue that you should start with the right-hand side. So tangent of pi over 4 plus x equals, okay, you should remember the formula by now. Let's see if I do. So this equals tangent of the first times tangent of the second over 1 minus tangent of the first times tangent of the second. Okay, so this according to the formula, this is going to be tangent of the first, which is pi over 4, times tangent of x over 1 minus tangent of the first. Okay, so I messed up the formula. There's a plus somewhere. Plus. It's 1 at the top is plus, not times. At least there's only like 6 new formulas, right? That's still a lot. So this should be a plus, guys. Plus. And then 1 minus tangent of the first times tangent of x. All right, so I know that tangent of pi over 4 is 1. So this is going to turn into 1 plus tangent of x. And at the bottom is going to be 1 minus, I know that tangent of pi over 4 is 1. So 1 times tangent of x is tangent of x. So you see how we showed that this equals that. All right, so I think we're just going to stop here. And when we come back from the break, we'll do these last 2 pages. And on Tuesday, we will practice with this stuff. And then on Thursday, you will be taking a quiz from it. So make sure you bring questions on Tuesday.